The Boy Who Harnessed the Wind is a deeply inspiring true story about a resilient young boy in Malawi who builds a wind turbine from scrap parts to save his family and neighbors from poverty and severe droughts. The main character, William Kamkwamba, uses physics and engineering to turn moving air into electricity. William found a book called Using Energy, and inside it, he saw a picture of a windmill. He saw an opportunity to better the life of his family and neighbors, but he couldn't have done it without some fundamental physics and science concepts. The most crucial piece of William's windmill is the dynamo that turns mechanical energy into electrical energy. A dynamo is a small electrical generator. It uses a principle discovered by Michael Faraday in 1831 called electromagnetic induction. Inside the dynamo is a magnet surrounded by a coil of copper wire. When the windmill spins the bicycle wheel, it turns the magnet inside the dynamo. When a magnetic field moves past the wire, it pushes the electrons inside the metal, creating an electrical current. But how do the blades start spinning? This was one problem William had to solve. Since he couldn't just put some wood in the air and expect them to spin fast enough, William took old PVC pipes, heated them over a fire to soften them, and hammered them into curved shapes to create airfoil blades. Because these blades were curved on one side and flat on the other, wind travels over the curved side faster than it does under the flat side. This difference in speed creates a difference in air pressure. High pressure underneath pushes the blade towards the low pressure above, and this pushing force is what's called a lift. And because the blades are set at an angle, this lifting force makes the entire rotor spin. Next, William found another problem with his windmill. At first, the wires in his room were strung up and the roof beams exposed. However, during a strong storm when his fragile straw roof collapsed in his room, they shorted together and almost caused a fire. A short circuit means the electricity suddenly has a straight path to flow through. Without any resistance to slow it down, a massive, dangerous surge of electrical current would rip through the wires. They would instantly overheat, sparking, making his dry thatch roof would catch on fire. So, William fell on the solution of a homemade circuit breaker. His circuit breaker is consisted of 2 nails with copper wire wrapped around them and a magnet acting as a switch. The nails act as electromagnets, and when electricity flows through them, they pull the magnet at the same time. The magnet stays in the middle because both forces are the same strength. When a short circuit happens or the windmill spins too fast, the force of one electromagnet will unbalance, pulling the middle magnet into it and breaking the circuit. This ingenious system prevents short circuits and protects against overload.